students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Analytical Engineering. So today we will discuss the reaction mechanism of addition polymers with some examples. So in the third module, engineering materials. So here are the topics. Let us understand the plastics. What are the plastics? Then compounding of plastics. Then in the classification, addition and chain growth polymerization and different types of addition reactions that are taking place through free radical mechanism, ionic mechanism and coordination mechanism with respective examples. Then emulsion polymerization is one of the type of polymerization which we will discuss with an example. So plastics. What are plastics? In the daily life we use for many applications plastics. So it is a substance that can be formed easily and molded into different shapes. So generally plastics are made from its granules. The granules are then molded at some temperature. So it is very easy to mold them in different shapes and sizes. And it can be formed in desired shape by either by mechanical force or heat and both. So mechanical force is nothing but what we use, the machines that we use for pressing and compression so that it forms in a desired shape at applied heat. So this is how plastics are made. So these are low cost. So the fabrication cost is very low, like molding machines only requires molding machines. Then low thermal and electrical conductivities. So high resistance to corrosion. So we have seen in our previous module that industrial applications, wherever there are some productions going on, the corrosion is a major drawback of metals. So in that we can use these plastics so that it will be resistant to corrosion and also to the solvents. So plastics also reduces noise and vibration in machinery. So when we talk about the production machinery, the use of plastics will reduce noise because the metal plates will make noise. However, plastics do not do. So they reduce the noise and also vibrations. And these are the bad conductors of heat. So thermal shock can be avoided. Then useful for making handles, also like handles and hot objects. So for handling hot objects like pressure cookers or the pans, if you see these handles, they are made of plastics. So this is how we have very good applications of plastics, and these are also the insulators. So we can use it in the electrical industry, like in the cables, and wires. So this insulation is made of plastics, this plastic material. So the copper wire is protected through this plastic. So this is how as an engineering material, plastics is widely used. Then compounding of plastics. So as such, the raw material, whatever we get from the reaction is really not sufficient to make a plastic for applications. So for that, we have to compound the plastics with some different materials. So mixing of different materials, like what are those? Plasticizers, fillers of extenders, then lubricants and pigments. These are some of the mixing materials that are required for a plastic to get some of the properties required for the applications. So these are sometimes added to the thermoplastics and thermosetting resins. So that will increase strength, toughness, etc. So these are some of the properties that are improved after adding these materials. So resins have, in general, the resins whatever are produced from polymerization reaction as such have some plasticity and binding property. So they have this property, but they need some ingredients before they are used for the fabrication of any applications. So if we see this diagram, we can see this is the resin part. This is the resin that is obtained from polymerization reaction. So through this reaction, through this process, we are adding fillers, plasticizers and some additives, so that will improve properties. So these are some of the materials that has to be improved to finally get the plastic granules. So these granules are further molded into different shapes, whatever are desired. So what are resins? This is a product of polymerization reaction. So during polymerization, whatever the reaction takes place, end product is nothing but resin. So this is the major portion of this plastics. So this forms the major portion of plastics, and it is the binder which holds the other constituents. As we have already seen, the other constituents like plasticizers or fillers, this is a major part that will hold these together. So this is very important. Then plasticizers, these are the substances added to enhance its plasticity. So enhance the property of plasticity in the material. Examples are like tricrysyl phosphate. Chemical materials are tricrysyl phosphate, dibutyl oxalate, and the natural one is the castor oil. So all these have some viscosity. See, if we see this tricrysyl phosphate, the solution looks very viscous. So these viscous solutions, whenever are added to the basic resin, that will increase the strength of the material and also reduces the cracking. It will reduce the cracking. So if we all know that if there is a plastic material like buckets or something, if it is cracking, it is of no use. So it is very important to add plasticizers into the raw material before manufacturing so that it will avoid cracking. What are fillers or extenders? These are generally added to thermosetting plastics to increase elasticity and crack resistance. So these also have similar property of reducing the crack formation and also increases elasticity in the polymer or the plastics that is manufactured. So examples are mica, the naturally occurring mica stone. We can purify and add it to the raw material resin. Then cotton or carbon black, graphite or barium sulfate. These are some of the examples of fillers or extenders that are added to the resins to improve the elasticity and reduce the cracking of that particular plastic. Then dyes and pigments. These are very important because whenever we are manufacturing some plastic material, if you see this picture, we have different colored articles. So how are these imparted? Because of adding these dyes and pigments. So we will impart some desired color to the plastics. So that will give some decorative effect. So examples are lead chromate and ferrocyanide. These are some examples, like lead chromate will impart yellow color and ferrocyanide will impart blue color to the plastic, and the materials will be in the similar color. Then stabilizers. Stabilizers are also very important because whenever the plastic is exposed to sunlight, the UV radiation can even react with the plastic. So for example, there are stabilizers like white lead or lead chromate that are added, which will improve the thermal stability of plastics. For example, in polyvinyl chloride, we add stabilizers that will improve the thermal stability of plastics. So at molding temperature, PVC undergoes decomposition and discoloration. So when it is discoloration, the color of the ultimate product will change. So that is why we have to add stabilizers to the plastic. Then coming to the reaction mechanisms based on the synthesis, there are two types: addition polymerization and condensation polymerization. So addition polymerization is also called as chain growth polymerization. So this chain growth polymerization, why are we really calling it as chain growth? Because it is extending the chain. So it is a chain reaction. Chain reaction, once it is initiated, once the reaction is initiated, the chain keeps on grows. So it is also called as chain growth. Chain growth polymerization. So it propagates until the chain is not terminated. So what does it happen? Like really, 3 steps are involved. Initiation of chain. When we start working, the initial step is very important, like initiation, then propagation, then termination. These are the three different steps that involves the addition polymerization. So there are three different types of mechanisms again. All the three mechanisms includes these three steps. So depending on the addition, there are three different mechanisms: cationic mechanism, anionic mechanism, and free radical mechanism. These two are together called ionic mechanism. Cationic and anionic together are called ionic mechanism, then free radical mechanism, and one more is the coordination polymerization. Coordination polymerization. So these are the different types of addition polymerizations that will take place so to form different materials. So depending on their addition mechanism, the strength and properties of the plastics vary, or the polymers will vary. So let us see with examples how the properties are varying and where are the applications depending on the properties we are applying those different polymers in different applications. So let us see the first one, cationic mechanism. In cationic mechanism, what happens? The reaction is initiated by an electrophile. So the electrophile initiates the reaction. How does it happen? There is an unsaturation in the monomer. This is a monomer we are taking. So this is the monomer we are taking and it has some unsaturation. So it will donate lone pair of electrons to the H plus ions. Lone pair of electrons to the H plus ions. So what happens? It is forming a plus ionic state. So nothing but this is called carbocation. This is called carbocation. So the chain is initiated by carbocation and thus it is called as cationic mechanism. So the reaction is terminated by the nucleophile. Ultimately, the reaction is finally terminated by nucleophile and therefore the initiator is an electrophile, intermediate is a carbocation and the inhibitor or the terminator is called is a nucleophile. This is how it takes place. Once it is forming a carbocation, again a monomer is added. This is the second monomer that is adding. So the chain is propagating. Forming a cation again. So this is how but however, at the ultimate step, at the end of the termination of this chain, there is a minus ion that is adding to this chain. Therefore, it is terminated by a nucleophile. This is how the addition mechanism takes place through cationic addition. So then comes the anionic mechanism. It is just the reverse of cationic, wherein the reaction is initiated by a nucleophile. So it accepts, the monomer will accept lone pair of electrons and then forms a nucleophile. So that carbanion. So this is a carbanion. So chain is initiated by an intermediate state, that is carbanion, and this will keep on increasing. This addition will keep on increasing and propagation takes place. And therefore, the termination should be the opposite ion that has to terminate. Therefore, electrophile will terminate this reaction and forming the ultimate product. So this is how the anionic mechanism takes place. So initiator is a nucleophile, intermediate is a carbanion, and inhibitor or the terminator is the electrophile. This is how the anionic mechanism takes place. So these are some of the examples. High density polyethylene is one of the example HDPE material that is forming through ionic mechanism. So ionic mechanism is nothing but involving both anionic and cationic. So let us see with this example and understand. So the linear polymer is forming. So HDPE is a linear polymer that is forming with little or no branching. So in this ionic mechanism, linear polymers are forming. So at a low temperature, of about 60 to 70 degrees centigrade and low pressures of 6 to 7 atmospheric pressure. So this is how the ethylene molecules will keep on adding and forms a high density polyethylene. This is how the HDPE material is synthesized. So the density of this polymer will be 0.945 to 0.965 gram per cubic centimeter. This is the density. So it is denser only. And it is also prepared. The other method is the coordination polymerization, wherein a catalyst is used called Ziegler-Natta catalyst, potassium persulfate and dibenzoyl sulfate, used in the formation of HDPE polymer. So in both the ways we can prepare HDPE material. So ethylene molecule is chain propagating, adding addition through ionic mechanism, and the chain is propagating to form a macromolecule, then forming the HDPE. So this is the condensed formula. You can write even C bond C and with H atoms taken n times. N times is nothing but chain. So if you see the structure also, the it is in the linear fashion with no branches. That is how it is called as linear polymer. So the properties are like it is opaque. So if we see any HDPE material, for example, buckets or some containers, it will be opaque. No, it is not transparent or it is not transparent. So it has less impact strength and better barrier properties. What is barrier property? Whenever we take water in bucket, it is leakage proof. So it is nothing but the barrier property, and better chemical resistance than HDPE. Better LDPE. So low density polymer. So we will see in details like LDPE also, and but it melts as 130 to 138 degrees centigrade. So these have very good applications because the melting point is also very high and it exhibits stiffness, toughness and good tensile strength and also heat resistance. If we see, for example, whenever we are taking buckets or dustbins or any containers, they don't melt so easily. So we have to send them for the recycling. It means the melting point is high. So they are heat resistant and have good tensile properties. So it has good applications in the formation and the manufacture of dustbins, cans, buckets and fuel tanks. So these are some of the good examples. And also corrugated pipes. So if we see these pipes, we generally use it for sinks and for other cabling purposes. So because they are resistant to chemicals, we can even use in the sinks also, say a pipeline in the sink. It is also used for the cable and wire insulations. So this is a cable jacket and these are the wires inside. There are 3 wires together. The insulation is happily like we can use it HDPE material so that it doesn't get damaged so easily. So this is how HDPE material has got good applications, and these are the properties of HDPE material. So let us see what is the free radical mechanism. The next one in the addition polymerization, it is like the reaction is initiated by a free radical formation. So the intermediate is also a free radical. So whenever there is a free radical formation, the free radical formation takes place continuously. So both the initiator, intermediate will be a free radical only. Therefore, it is called as free radical mechanism. So what does it ultimately mean? Whenever there is an addition of free radical, it has to be again terminated by a free radical only, because only then it will form a bond. So terminated by a free radical again. Therefore, the initiator is a free radical, intermediate is a free radical, and also inhibitor or the chain terminator is also a free radical. So this is how the free radical mechanism takes place. For example, if we have this monomer, we have a double bond or unsaturation. So this is a prerequisite for any addition polymerization reaction to take place. That is, the monomer must have unsaturation. For any addition polymerization to take place, the monomer should have unsaturation. So there is a bond cleavage between these 2 carbon atoms and therefore forms a free radical. The dot means free radical. Then again, second monomer is added. Second monomer is participating in the addition polymerization, again forming a free radical. So ultimately, the end of the chain or termination is also undergoes with the free radical addition. So this is how the ultimate polymer is forming. So let us understand with some example. So there are two different types or routes of free radical addition. So if, for example, there are two monomers, these are two monomers, first one and the second one, what happens? These two chains will collide with each other. Collides with each other and couples. In this way, both the chains are terminated and the polymer chain has molecular weight more than expected. So this is how one of the way where the free radical addition takes place. So this is the first monomer and the second monomer. The free radicals collide with each other and forms a polymer. So this has, if we see this formula, this has molecular weight higher than whatever we are expecting really. Molecular weight is high, increase. Then the other one is the disproportionation. So what happens in this? Hydrogen radical from one propagating chain can be abstracted by the other one. So what happens? This hydrogen from second monomer is abstracted by this first monomer. So what happens in that case? It forms a polymer. So it forms again a monomer. So unsaturation is created. Unsaturation is created in the second monomer. In the second monomer, unsaturation is created. Unsaturation or the double bonds. Second monomer is unsaturated in this way. So that will again continue in the formation of free radical and the chain terminates again with the free radical. So this is how there are two ways wherein free radical mechanism takes place. So an example for this is the polyvinyl chloride. So this is a homopolymer. It means one type of monomer is used in the formation of this polymer. So its monomer is what? Vinyl chloride. Vinyl chloride, keep on adding, forms polyvinyl chloride. So vinyl chloride. This is vinyl chloride. What is the other name? Chloroethane. Chloroethane. So this upon addition forms polyvinyl chloride. So it is also called as thermoplastic polymer. So thermoplastic, it has some reaction with the temperature. Thermoplastic, it means it reacts with temperature. So thermoplastic polymer. So these PVCs are again two types. What are the unplasticized PVC and plasticized PVC? So these unplasticized PVC will be rigid. So it will be hard and strong enough and also flame retardant. So it doesn't catch flame so easily and has good chemical resistance. So unplasticized PVC has good flame retardant and chemically resistant. Plasticized PVC is PVC in which chemical agents called as plasticizers are incorporated. It is just by the name we can understand that whenever it is plasticized PVC, plasticizers are added to the PVC so that it becomes more flexible. As we have seen already in the initial slides, like plasticizers will improve the elasticity and therefore it becomes flexible in nature. So this is how there are two types of PVCs. So if we see this reaction, this is a vinyl chloride and this is a vinyl chloride with some radical formation, free radical formation, the chain propagates in the polymerization reaction. So what are the properties? It is colorless, odorless and non-flammable material. So it is colorless, odorless and non-flammable material. So it is chemically inert and highly resistant to acids, alkalis and except plasticized PVC. So that is how it depends on the properties. With the properties, the application varies. So resistant to atmospheric oxygen and possess stiffness, rigidity compared to polyethylene, and it has lightweight, durability and easy processability and is therefore used as a building material, replacing wood, metal, concrete. So if we see here, this man is installing PVC for the housing purposes. Whenever there are some countries wherein there are houses that are built very frequently, so in that cases they use these materials so that the cost will be reduced. They can replace wood, metal and concretes. And there's also applications like in pipes, flooring and vinyl siding. Nothing but we are using it for the windows or wall applications, and also flooring. These are the flooring for the PVC that is used in the flooring, the carpets. Then wire and cable insulations. Again, PVC is chemically resistant and electrical resistant, so therefore used in the wire and cable insulations. Then pool liners. If we see, this is the pool liner. There is a very colored pool. The blue color, whatever is reflected, is because of that lining that is inside the swimming pool. Then roof coating. On the roof, if we can coat this with PVC, it will be corrosion resistant and also can withstand leakage proof. So then carpet backing and raincoats. If we see, this kid is wearing a raincoat that is made of PVC material. So these are very good applications of PVC material synthesized from addition polymerization reaction. Then polyethylene. So other example is a polyethylene that is forming from a free radical mechanism. So it is a monomer, a homopolymer. It means the monomer used is ethene or ethylene. Only one type of monomer is used. Therefore, it is called as homopolymer and is mostly used in all the plastics. Polyethylene is the general word everyone, even the layman understands, is a plastic. It is used in all types of plastics. So it is again two types, low density polyethylene and high density polyethylene, as we have already seen. Like these are the two different materials that are formed with the ethylene or ethene monomer, forming two different materials depending on their densities. So low density LDPE is a polymer of low density. So it is prepared by free radical mechanism at temperatures of 80 to 130 degrees centigrade. So it is forming at a little bit higher temperatures only. This is at high temperature only, like 80 to 350 under pressure of 1000 to 3000 atmospheric pressure. So this is also high pressure in the presence of oxygen. If you remember that HDPE is material that is prepared with low temperature and low pressure. LDPE is prepared at high temperature and high pressure in the presence of oxygen. And therefore, the density, what is the density? 0.91 to 0.94 gram per cubic centimeter. So this is the density of this polymer. Therefore, low density compared to HDPE. When the density decreases, the transparency increases. So we will see in the properties. So if we see in detail the polymerization reaction, there is a free radical formation because of an abstraction of hydrogen atom. So the chain A terminates. However, the chain B is propagating due to addition of one more monomer here. So finally forming branches. This is the branch polymer. So linear polymer is HDPE, branch polymer is LDPE. These two is very important to remember. Linear polymer is HDPE and branch polymer is LDPE. This is how the branches are forming. So one is the important point to understand is free radical mechanism will form branches due to its addition reaction. So this is very important to understand and remember. So due to this branching of polymer during this mechanism, it forms waxy transcalent material, and then high impact strength, just having a high impact strength, low brittleness temperature, and film transparency. Just opposite to HDPE. HDPE is opaque. Here it has some transparency. For example, if you see the packing material, These are the packing material that we use for the food wrapping when we buy it from stores. And also these polythene bags, if we see, they are transparent enough. So this is how we have to just remember. And it has got, however, got insulating properties. So they are electrically insulating. Still they are insulating because of polymer property. And they are also chemically inert and also has good resistance to acid and alkalis. So, however, the temperature of melting is low, like 107 to 120 degrees centigrade. If, for example, if we just leave the polythene bag near stove, it catches the fire. It is nothing but having low temperature, like cooking temperature, like 107 to 120 degrees centigrade is very low and is flexible at wide temperature range. So that is how we are able to manufacture polythene bags. Then it is used in the packing material for food and garments. Wherever we buy some clothing, we get polythene bags. So that is nothing but LDPE. If we just check on the bag, there will be some mark like this, LDPE with some number, 1 or 2, or it depends on the recycling process. If it is marked like this, it is recyclable. So that is how we have to just take care of polythene bags whenever we are getting polythene bags. So only if we need, we have to take the polythene bags. So this is again used in squeeze bottles, nothing but the bottles that we use for the DI water or the purified water. And coatings and wrappings, then cables and insulation wires. Commonly, if we see, all the polymer materials are used in the cable and wiring. So there are different types of cables. So if we see this type of cabling, it will be some elastic. It has some elastic property. So and also smooth. So in that type of insulations, LDPE is used. So these are the applications of LDPE with the properties that are outstanding for flexible applications. Then the other type of polymerization reaction is the coordination polymerization reaction, that is in the addition polymerization. It is carried out in the presence of Ziegler-Natta catalyst, triethylene aluminium and titanium tetrachloride. So this is the catalyst that is used. Catalyst name triethyl aluminium and titanium tetrachloride. A combination is nothing but Ziegler-Natta catalyst. So for example, ethene monomer for HDPE formation only, if we see, HDPE is again can be formed through this coordination polymerization reaction. Ethene monomer approaches towards the catalyst surface titanium. So this is the monomer approaching the titanium catalyst, the metal, and forms pi complex due to the lone electron lone pairs. It uses the pi electrons and interacts with the alkyl group, yielding a transition state. This is the transition state complex. So the pi bonding is taking place. Let us see here. See, here is the pi bonding between the monomer and the metal. So this is how the complex forms, and then the titanium alkyl bond breaks and forms titanium monomer. So these bonds break and forms. This is the transition state. There is an rearrangement, and this is how it forms transition. Titanium and alkyl bond breaks and titanium monomer forms. Titanium monomer. Titanium monomer. This is the titanium monomer. This is how it keeps on adding again one more monomer to this. Again CH2, double bond CH2 will add again to this, and the chain continues. This is how addition polymerization takes place through coordination bonding. So what is the significance of this coordination polymerization? So it will produce branch-free polymers. Branch-free polymers. Since chain stands already terminated, and as also the monomer units added is between the catalyst surface and alkyl group. So wherever the monomer is adding, it is between the catalyst surface titanium and the alkyl group. Therefore, there is no chain formation. So it is used in preparation of highly stereoregular polymer. So depending on our application, we will be using different types of polymerization reactions to obtain desired product or the polymer. So the other type is the emulsion polymerization. An example, best example is the Teflon or the PTFE, polytetrafluoroethylene compound or the polymer that is forming through emulsion polymerization reaction. So it is a monomer again. So we are using only tetrafluoroethylene as one unit, a monomer unit. So therefore called as homopolymer. So it is a thermoplastic polymer. So it is usually prepared by emulsion polymerization of tetrafluoroethylene using peroxide or ammonium persulfate. So these are two acts as an initiators. So for example, if we know emulsion, oil and water together, when it is mixed, it is called as emulsion. So that is how we, if for example tetrafluoroethylene is a monomer droplet, so this is the monomer droplet, tetrafluoroethylene, and using peroxide or ammonium persulfate, these will act as an initiator for the chain propagation. So these, whenever these are added, that will form the chain will keep on increasing. This is how, let us see these in the reaction. So if we see here, these are the chain formation, monomer droplet, and then we are adding the initiator. These are the initiators we are adding, like peroxide or ammonium persulfate, and then monomer particles are forming, or the polymers are forming, polymer particles are forming. So these will combine together, and during polymerization it will form PTFE, or also called as Teflon. So if we see, we will generally use these most widely in Teflon taping and Teflon waves, Teflon beakers, and also we will see the applications also. So this is how PTFE polymerization takes place. So the polymer is highly crystalline, like around 93 to 98% crystallinity, and has good chemical resistance. So this is why we use Teflon in laboratories also, like Teflon ware in reactions, during reactions with any HF or any high concentrated acids, and is also insoluble in all solvents. So it is insoluble, then low coefficient of friction, and remains slippery. And it has got very good insulating properties, like other plastics. So in industries, we are using for knobs, then fittings, then some gears, and so on. These are having good strength and also have insulating properties and chemically resistant. So therefore, we have good applications both in industry and domestic. In domestic, how are we using? Non-sticky coating on frying pans. So if you see this, here like Teflon coated pans, it is nothing but PTFE that is coated, and also the iron box that is coated with PTFE, so that it is smoother enough. Then used on weapons as anti-corrosive coatings. On weapons, like whatever we are using, it will avoid the corrosion that will take place for the metals. Then coating on pipes and tanks, just avoiding the corrosion again. Dry lubricant on the burette stoppers. So even in the chemical lab, we use for the funnels and other applications like burettes and stoppers, and the Teflon beakers or the standard flask, etc. So these are the wide applications that we have for the PTFE or Teflon. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.